In this question, we want to look at that given production function, how do we first check whether it exhibits decreasing returns to capital or not? For this, we'll first recall what do we mean by decreasing returns to capital. So recall, decreasing returns to capital means returns to capital means increases in K with fixed N leads to smaller and smaller increase in output. So basically when you increase K, output will increase, but the rate at which it's increasing will go down as you keep on increasing K. So now that we know what decreasing returns to capital means, let's check whether the given production function exhibits this or not. So checking decreasing returns to capital. Now, how do we check this? Let's see what our production function is. Our production function is y is equal to fkn, which is given to us as k 1 by 2 n 1 by 2. Now the marginal product, let's first find what the marginal product of capital is. Marginal product of capital is the additional output that can be produced when you increase capital by 1 unit, keeping labor fixed. So this is partial y by partial k. So we'll differentiate our production function with respect to capital. So when we differentiate this with respect to capital, we'll apply, we're treating n as a constant, so we'll just apply the power rule here. The power will come down and we'll reduce the power by 1. So n 1 by 2. And then we can write this as 1 by 2 k minus 1 by 2 and 1 by 2, and this is greater than 0 because when you're using more capital, output is increasing. What we want to see is this output increasing at a decreasing rate? So we'll find what partial mpk. Now we'll differentiate this marginal product of capital with respect to k to see as we keep on increasing k, what happens to the additional output that is being produced. So this is essentially going to be, because we're differentiating this with respect to, we're differentiating marginal product of capital with respect to k. So that means we're taking another derivative of this with respect to k. So this is partial square y by partial k square. This is the second derivative of our production function with respect to k. Again, we'll apply the power rule here because when we're differentiating here with respect to k, we're treating n as a constant. So we'll take the power down. So it becomes minus 1 by 2 times 1 by 2 minus 1 by 4. K becomes minus 1 by 2 minus 1 and n 1 by 2. So this becomes minus 1 by 4 and then this becomes minus 3 by 2 n 1 by 2, and this is less than 0. Because this is less than 0, so the idea is that as k increases with fixed n, so we're keeping n fixed and we're just increasing k, the marginal product of capital, which is partial y by partial k, goes down, right? This is what this is telling us. Okay, when I increase k with n fixed, the marginal product of capital is decreasing. And what is the marginal product of capital? The additional output that you can produce when you use one more unit of capital, keeping labor fixed. So we have smaller and smaller increase in y. So smaller and smaller increase in y. So y is increasing but at a decreasing rate. Smaller and smaller increase in y.